Here are the solutions to your study session 1 packet. I have divided this up into 3 different videos, and the first one is your limits. So for this particular problem, the graph of the function f is shown above. If the limit as x equals b of f of x exists and f is not continuous at b, then b has to be which one of these values along the x-axis. So our limit exists, but f is not continuous. So that tells me we're looking for maybe a hole in the graph. So let's look up and see, where do we have a hole in the graph? Because that pH, goodness. So that tells me that as I'm approaching from the left and right of a value, I'm approaching the same value from both sides. So if we look here and here, it looks like we are approaching the same y value from the left and right, but I am not going to be continuous here because of that open circle. So to me, it looks like the correct answer here should be B. Okay, so number 2, similar idea. We have to make sure we're approaching the same value from the left and from the right. So in doing so, very quickly looking through all these values, hopefully you would notice this area right here, because my graph is really broken up here, and as I'm coming in from the right and then from the left, we're approaching 2 different values. So let's look and see, do I have a limit anywhere x is approaching 4? Yeah, that's going to have to be a false statement. That's definitely not true. So your answer here is C. All right, for this problem, we're asked the line y equals 5 is a horizontal asymptote. So I would stop there, and when I see horizontal asymptote and I have y equals 5, I'm looking for Betsy. I'm looking for a limit as x approaches infinity. And this Betsy, that was just a quick way for us to remember bottom equals top is the ratio of the coefficients that contain those exponents. So here we have to be careful in looking at these limits. Now, if we remember with A, I think A is a little tricky here, because this one, you do get 5 when x is approaching 0. Of here's sine of 5x over x. This is going to generate an answer of 5, but now it's not generating a horizontal asymptote because x was approaching 0. Now for B, this is just the line y equals 5x, so that's not talking about a horizontal asymptote. As we continue on here, well, this is going to be a vertical asymptote. That's going to be x equals 5. So notice all of these are dealing with 5 in some capacity. Look at part D. Y equals, this is a Betsy, but notice when I look at the ratio of my coefficients, it's 5 over -1 or -5. So we have to have E as our answer choice, but let's make sure we've done everything correctly. So if I look here and we do the limit as x approaches infinity, we're looking at our case for Betsy, we get 20 over 4, which is going to generate the correct answer. So here my answer is E. Right, number 4 is a little different. This notation looks very strange here. You want the limit of f of g of x. Now, there's a lot of times people try to start these a little bit of a backwards way of doing this. What we need to realize is the limit of this composite function. We can actually move one of those functions out and say, really, I need f of the limit as x approaches 1 of g of x. And then once we find this value, then I can plug that value in to f and then actually find that final value. So the limit as x approaches 1 of g of x looks like it's going to be 2, doesn't it, if we look at our graph of g of x. So really this is talking about f at 2. And then if we move over to this other graph, we see that f at 2 is going to be 3. So my final answer is C. So the problem wasn't that difficult, but we need to realize that we can move out that function and then find the limit on the inside and then take that value and substitute into the other. Okay, so number 5, this is back to horizontal asymptote. That's what this is asking. This is the same thing as a horizontal asymptote. And here, a lot of times students look at just the first two. Again, you have to find the highest exponent on bottom, highest exponent on top, and then look at the ratio of their coefficients here. So I have x squared over negative 4x squared. That's really going to be dominating what happens as we approach infinity. And notice that's really going to reduce down to a negative 1/4. So my answer here is B. Very similar to the previous problem, as we're going through, again, x approaching infinity, well, what's the highest power on top? Well, it's under the radical, but we can still look at this, the square root of 9x to the 4th, and that's going to be dominating what happens on top, and what dominates on bottom, x squared. And it looks like on top we can reduce this to be a 3x squared over x squared. And again, we have a Betsy. The bottom equals the top. Ratio of my coefficients would be a 3 to 1, which is 3. So my answer here is B. Okay, so looking at number 7, we have the graph of the function f is shown for how many values of x in the open interval from -4 to 4 is f discontinuous. So we're looking for where that might be discontinuous. So we're looking for holes in the graph, breaks in the graph. So looking over all of this, well, we are discontinuous. Now, it's not talking about a continuous domain. Let's not confuse that. We're talking about the actual function itself being discontinuous. And it looks like here we would be discontinuous. Here for sure, my gracious, that's discontinuous, and here. So we have 3 places where we're not continuous. All right, and so for number 8, let f be the function defined above. For what values of k is f continuous? So let's think about what happens here. So if we go back to the wrong setting here, let's think back to graphing rationals. What happens to that? Well, those two cancel, and you're left with f of x equals 2x plus 1. But remember, what we canceled out, that x minus 2 generates a hole in our graph. We've removed that. So we have a hole in our graph at x equals 2. Well, what's the y value that would go with that? We need to pinpoint where that hole is in the graph. So we would come back over and see, well, where exactly is that hole at? And if we plug in, we get 5. So I know I have a hole at the point 2, 5. So I have a graph, and let's see, our y-intercept is at 1. And we go up 2 over 1, 1, 2 over 1. And so we're going to continue this, but when we get to 2, we have an open circle. We have a hole in that graph. Now what this is saying is Well, this is what we have going on with the function. For what value of k would make f continuous at 2? In other words, what value would k have to be when x is 2 for us to be continuous? Well, it would have to be 5. It's the y-coordinate of the hole in the graph. So my answer here should be E. Okay, so for number 9, we need to find the derivative, then plug in, and let's be careful with our notation. Always show the derivative first, then plug in, especially on free response. Now, multiple choice, nobody really cares, but free response, you need to get in a good habit of doing that. So our derivative of 7x is 7. The derivative of negative 3 is 0. The derivative of the natural log of x, that's going to be stuff prime over stuff. Stuff is x. What's the derivative of x? It is 1. So now I need f prime at 1, which looks like I'm just going to get 7 plus 1, which is 8. So here my answer is E. Now remember, the natural log, if we want the derivative of the natural log of stuff, and we always called it stuff, you can insert whatever S word you want. The derivative of that is 1 over, stuff prime, I'm going crazy, stuff prime over stuff. The derivative of stuff over stuff, every time. So for number 10, it looks like we need to do our product rule. Remember, you do have x and then times sine of x, so there's your two functions. So when we start doing y prime, we have first times the derivative of the second, and we do need to take the derivative of x, but that is just 1. So first times the derivative of the second plus the second times the derivative of the first, which again, derivative of x is 1. And so let's see which answer choice is going to match that. Well, we have x cosine x plus sine x. So it looks like answer choice B. All right. Now for number 11, we're still doing our derivative. Now let's see, this, we need to do some rewriting here. This is a tricky problem. F of x equals that exponent. Let's move that bad boy to the outside. That way we see our chain rule that we need. So here is the entire problem rewritten. So when I do f prime at x, I get 2 times sine of 3 minus x, all to the first, times the derivative of the inside. Now the derivative of the inside, we've got a couple of things here we're going to have to do. Well, the derivative of sine of 3 minus x is cosine of 3 minus x, and then that's going to be times the derivative of 3 minus x, which is negative 1. So we have to be careful. It's the never-ending problem. Now that we have our derivative, let's find f prime of 0. Well, that's going to be 2 times sine of 3 times cosine of 3, and then that negative 1, I'm just going to throw that negative there to the front. So let's see, the only answer that's even negative is A and B, and it looks like my answer should be B. Okay, more derivative fun, yay. Now we definitely need to do the chain rule. And looking at this, let's go through our answer choices. Since we know we need the chain rule, we have this exponent out here. So we need to multiply the 5 down and then subtract 1. But then we'll also have to take the derivative of the inside stuff. And notice A and B are just jacked up versions of that. And it almost looks like, so is C. C didn't even get the exponent right. So very quickly we notice that here we're left with D and then E, but notice here they did a derivative, and we're not ready for a derivative when we're doing our power rule first. So my only answer choice there would have to be E. So we could very quickly go through that to show you what I'm talking about step by step. Well, y prime would have to be, in our chain rule, we address the power rule first. So we have this. You're not going to do the power rule and the derivative on the inside at the same time. That's just crackheads do that. Y'all are not crackheads, so let's not do that. And then after we have our power rule established, then you do the derivative of the inside, which is going to give us 3x squared. Derivative of cosine's negative sign, so that's all going to flip to a positive sine x. And then the derivative of x, which is 1, so we don't have to worry about it. So again, see that we got the same exact answer by just reasoning through what we know should happen with this problem. Okay, so let's see, for this one, we are looking for the derivative of f of g of x when x is 3. And this one tends to get people because they want to plug in 3 and then try to do a derivative. You can't do that. The first thing that you need to do is find, well, what's the derivative of f of g of x, which is again chain rule. F prime of g of x times the derivative of the inside, which is g prime of x, and then times the derivative of x, which is just 1. Now you can go through and substitute in your 3. So f prime of g at 3 times g prime at 3. And now we can start plugging in. Well, we need f prime at g of 3. G of 3 looks like it's going to be 7 times g prime at 3. Well, g prime here is just 3. So that's going to be 3. So now I need to find f prime here. So, well, I don't like that arrow there. So f prime, remember that has to be all raised to the 1/2 power. So that's going to be 1/2 x squared minus 4 raised to the negative 1/2 because I'm subtracting 1. And then times the derivative of the inside. Now let's see, those 2's will cancel. So f prime is going to be x over the square root of x squared minus 4. Now I want f prime at 7. So that's going to give me 7 over the square root of 45. And let's see, 7 over, that's 9 times 5, so 3 root 5. Now I'm ready to come back over here and plug in. And so I have 7 over 3 root 5 times 3. And put that over 1. Those are going to cancel. So I have 7 over the square root of 5. So that leaves me answer choice A. All right, another function to find the derivative of. So, and this looks terrible, but all of this is just the angle. So don't freak out. Take it a little bit at a time. So f prime at x is equal to, well, the derivative of sine is cosine. And we need to continue with all of this angle business. So natural log of 2x times the derivative of the angle. Well, what's the derivative of the natural log of 2x? Well, that's going to be stuff prime over stuff. Here's my stuff. So over stuff. That's always the denominator. And what's the derivative of this denominator? Well, it's just 2. And so those 2's can cancel. So really, this derivative wasn't that terrible. We're going to end up with cosine the natural log of 2x all over x. And let's see, what answer choice does that look like? It looks like B. Okay, this problem is a calculator active problem. And let's see, it is telling us that the temperature in degrees Fahrenheit of water in a pond is modeled by the function h. And then it's given us h, which looks horrible. Where t is the number of days since January 1st. What is the instantaneous, oh, there's good stuff right here. What is the instantaneous rate of change of the temperature of the water at time 90 days? Well, when we see IROC, we need to think derivative, or in this case, h prime at t. And since this is a calculator, we can type all this in our calculator. So we would go to our menu, and then we would choose calculus. And then we need a derivative, numerical derivative. And you would type all this information in. Once you do that, and do make sure your calculator is set to radians, once you do all that, your answer should be B. All right, here's a great problem that we'll be looking at quite a bit in our review material. Now, this looks awful familiar to what we talked about earlier. The limit as h approaches 0 of f of x plus h minus f of x all over h. This is going to be our limit, or just our definition of a derivative, and we worked out, and you should have notes on this, and that's going to be equal to f prime at x. And so what we need to do is realize, hey, this is really asking us for the derivative, and we're asked for the derivative when x equals 4, because notice the 4 has been replaced, or replacing the x in the problem. So we need to identify, well, what is f of x in this problem? And f of x is always right here, it's sitting there, that's the very last part. So my function itself was the natural log of x. And so f prime is going to be 1 over x. Remember, stuff prime over stuff. And this sitting here is the stuff. It's the stuff. And so now I need to find, well, what is f prime at 4, which we all see as 1/4. And so you end up with B for your final answer. Okay, this problem is very similar to the last one. Again, we're talking about the limit definition, or a definition of a derivative. And again, that limit as h approaches 0 of f of x plus h minus f of x all over h. That is talking about f prime at x. And now when we go through, we identify, here's my f of x, and I need that value, or the derivative value when x equals 3 pi over 2. So if f of x is cosine of x, so then we know f prime is negative sine of x. And now we need to know, well, what is f prime of 3 pi over 2? Well, that's going to be negative sine of 3 pi over 2. And that's going to be negative of negative 1, which is positive 1. So we should have gotten A for my answer here. Hey, this problem is very tricky. Not to say the other ones aren't, but looking at this, first thing, especially after the previous problems, we see that this is talking about the derivative. And we're really talking about the derivative at x equals 3. And if we just glance up here and we look at the derivative, since these are linear functions, we see pretty quick that, yeah, if I do the derivative of the top and derivative of the bottom, we're going to have 2 as an answer. And so it's very tempting to want to choose D. But if we investigate this a little bit further, notice we're just told that we have a piecewise linear function defined above. At first glance, if I plug in, and this is just one of the things we have to be careful about, if I plug in 3 into the top, I get 2 times 3 minus 2, which is going to give me 4. And then if I plug in 3 into the bottom part, I get 2. So this is really telling me that I'm not continuous at 3. This is illustrating the limit as x approaches 3 from the left of my function. And this one's talking about the limit as x approaches 3 from the right of my function. So notice these two values, they're not meeting or coming toward the same y value. So this tells me that we are not continuous at 3. So if we're not continuous at 3, we can't be differentiable. We have to make sure we establish continuity at that point. Here we're not continuous at x equals 3. So really the only one-sided limit that we could talk about, and I'm saying one-sided because h is approaching 0 from the left and the right, we can only talk about the one that is containing 3. That's the only one that could possibly be true. And notice here, what is the derivative of this portion? Well, it's 2, which is what I got when I plugged in my 3. So this one can't be true because, again, my limit is showing me that we're not continuous, so we can't really talk about our 3 being able to look at the derivative here because 3 is not contained in that endpoint. Well, if we're not continuous at 3, we certainly can't say we're differentiable. Now, the one-sided limit, sure, because we're only looking at one side of the function. So the only one that could possibly be true is part B. So this one was pretty tricky. It kind of made you want to assume that we were continuous because it jumped straight to the derivatives. But if you go back and look, you're not continuous at 3. So 1, 2, and 3 all could not possibly be true. Okay, with number 19, the graph of a piecewise function. The graph has, and this is pretty important information they're giving us, the graph of f has a vertical tangent line at x equals -2. So here at x equals -2, we have a vertical tangent, and so that tells me that f prime is undefined because here vertical lines have an undefined slope. And then we're told horizontal tangents at x equals -3 and -1. So I have horizontal tangents here and here. So at those two places, I know f prime equals 0. So what are all the values of x over the interval from -4 to 3 at which f is continuous but not differentiable? Continuous but not differentiable. Well, let's look at our answer choices and see, well, can we figure out where this might be? Well, the first choice they give us is x equals 1. Well, if we look, we do have this sharp point at x equals 1. So I would think that's true. You're not going to be differentiable at those sharp points. So that one's true. And before we celebrate, though, we look at our other answer choices, and 1 is also in C and D. So the only thing we can do is get rid of B. All right, so let's look at C. We already know 1. What about at x equals -2? Well, they told us up here at x equals -2 that we had a vertical tangent, and that means f is undefined, f prime is undefined, so we're not differentiable there. So that tells me that my answer has to be C. Now, why not 0? Well, 0, it doesn't meet the f is continuous. So here, f is not continuous. So that's why that one could not be an answer choice. So be careful in that. Make sure you check continuity before you do your derivative. Okay, number 20. Let's see, with this limit, I would go ahead and plug in. That's always a good place to start. So if we plug in, we have cosine of pi plus sine of 2 pi plus 1 all over pi squared minus pi squared. So pretty quick, I see the denominator is 0. The numerator, cosine of pi is -1. Sine of 2 pi is 0. And then we have a positive 1. So we have a 0 over 0, which does not automatically imply does not exist. We have to be careful. Now we have to do what's called L'Hopital's rule. Every time we have an indeterminate form, that means L'Hopital. And L'Hopital means we're going to estimate the limit by looking at the derivative of each individual term. And so the derivative of cosine, negative sine of x. Derivative of sine is cosine, but now we have 2x, and we have to multiply by the derivative of 2x. Derivative of 1 is 0, all over, and derivative of the denominator is 2x. Now we go back and we reevaluate. So here I would have negative sine of pi plus cosine of 2 pi minus 2, and all of that is over 2 pi. So let's see if we can't go through and reduce this sum and see what we get. Well, sine of pi, that's going to be 0 again. Cosine of 2 pi is going to be positive 1. And so let's see, when we start working out, let's see, we've got 1, 0 plus 1 times 2. So I'm going to have 2 over 2 pi. Well, 2 over 2 pi, that's going to reduce to 1 over pi. Okay, again, let's go ahead and plug in and see what we get. So when we plug in, we're going to have 0 minus 0 over, oh, it looks like a 0 festival here. So we definitely get 0 over 0 again. That's indeterminate. So we need to do L'Hopital's rule. And so let's look at our limit now based on our derivatives. So let's see, the derivative of 7x is 7 minus derivative of sine is cosine, and derivative of x squared is 2x. And let's see, the derivative of sine 3x is cosine 3x times 3. Okay, now let's evaluate or plug in for my limit. So I'm going to have 7 minus cosine of 0 is 1 over 0 plus, and again cosine of 0 is 1, 1 times 3 is 3. So it looks like we're going to get 6 over 3, which is 2. So your answer should be B. All right, for time greater than or equal to 0, the velocity of the particle moving along the x-axis is given by a velocity function. And this is asking at what times of t is the acceleration of the particle equal to 0. So to get our acceleration function, we go and find the derivative of the velocity. A couple of ways you can do this. It might be easier for some people to multiply all that out and then do the derivative. And then the other way would be your product rule. It really doesn't matter. So let's see. A at t equals, and so we have our first times the derivative of the second, so it's going to be 2 times t minus 2 all raised to the first times the derivative of the inside, which is just going to be a 1, and then plus the second t minus 2 all squared times the derivative of the first. Well, the derivative of the first is 1. So let's see if we can't simplify some of this. We have t minus 5 times 2 times t minus 2 plus t minus 2 all squared. Now this is going to require us to do some factoring, and looking at the factoring, notice you have t minus 2 in both terms, so we're going to factor that out. So I have a of t equals, and I'm going to factor out t minus 2, and let's see what's left over. Well, we have 2 times t minus 5 plus, and we had 2 t minus 2's, we factored out 1, so there's 1 left. Now, keep in mind, we're looking for where acceleration is 0. So if I set this equal to 0, then I see pretty quickly that t equals 2 is 1, but then I also have other stuff over here. So I can get rid of, hopefully, those two. And so let's look over here at this. We can go ahead and multiply this out. So I have 2 times t minus 10, and then here plus t minus 2, that's all equal to 0. And then combining these terms here, we have 3t minus 12 equals 0. And if we solve for t here, we see that t is going to have to be 4. So my correct answer is C. And again, if you did not want to go through this, you're more than welcome to full this out, then multiply this through, and then factor that way. And it'll still generate the same answer. All right, another non-calculator. For what values of t is the speed of the particle increasing? Couple of ways to do this one. If speed is increasing, then we know velocity and acceleration have the same sign, both positive or both negative. But we also know that my speed function is equal to the absolute value of velocity. So it might be a good idea to graph velocity. If we can do that, and that'll make the problem a little bit easier. So how do we get velocity from position? Well, you take the derivative. So v of t equals, we have 6t squared minus, what is that going to be, 48t plus 90. And then I would find the zeros of this function. And it looks like we can divide everything through by 6. So that's going to give me t squared minus 8t plus 15. And that's going to factor real nicely. Let's see. 0 equals, we have t minus 3 times t minus 5. So we see that we have 3 and 5. So t equals 3 and then 5. Now we need to graph this if we can and see, well, where in the world would I end up with speed being positive? Well, if we look at the graph, 3 and 5, we know we have a parabola because this velocity was squared. And here we're crossing at 3 and 5. Now, let's go back to the idea that speed is the absolute value of velocity. Because if we remember that, then if we're taking the absolute value, that means all of this stuff here gets flipped over. And so this in red is really the graph of speed. Now we need the vertex here, that x value, which is going to be our axis of symmetry, which is in the middle. So we could say 5 plus 3 divided by 2. So that's going to give us 4. So we know 4 is going to be the x-coordinate of the vertex. So we now have our speed function, and we need to know for what values is speed increasing. Well, speed is increasing from here, let's see, from here to here. And where else is speed increasing? From here to here. So let's look at our answer choices and see, well, which one is that going to be? So we have from 3 to 4, and then from 5 on. So it looks like we have answer choice E. Okay, so for 24, a particle moves along the x-axis, and we have our position function, and we want to know, well, when is the particle at rest? Now we know the particle is at rest when velocity, when v at t equals 0. So that means we're going to have to take the derivative of this mess. Well, let's go through and see. So velocity, and we can do our product rule. We'll do the first times the derivative of the second, which is just going to be 1. Remember, a and b are constant, so the derivative of t is 1. So first times the derivative of the second plus the second times the derivative of the first. And let's see, let's go ahead and see what we can put together here. So all of that's going to be t minus a plus t minus b. And then if we collect our terms, we have 2 times t minus a minus b. And now if we set this equal to 0, we have 2 times t minus a minus b. Now remember, we're looking for the time t, so we're solving for t. So it looks like we need to add a and b over, and then that's going to give us 2 times t, and then we would need to divide by 2. So we get a plus b all over 2, which is going to be b. Okay, this is a calculator problem, and you're given 2 position functions, sine of t and e to the negative 2t minus 1, and you're asked how many values of t do the particles have the same velocity. So what we need to do for this problem is to graph each one of these functions, and really we need to graph the derivative of each function. And then after you do that, you need to find points of intersection. So we need to graph the derivative of each function and then find their points of intersection, but it's over the closed interval from 0 to 10. And this is a problem we'll do in class, but if you want to try it, please, I encourage you to do so. The answer here is D. Okay, back to a non-calculator problem. 26, the position of the particle moving along the x-axis is given by this particular function. What is the acceleration of the particle at the point where velocity is first equal to 0? So the first thing we need to do is find v at t, which is going to be our derivative. So the derivative of sine of t is cosine of t, minus the derivative of cosine is negative sine, so that's going to change that. And we want to know also acceleration, so let's go ahead and find the acceleration function while we're doing this. So we have negative sine of t plus cosine of t, and we want to know the velocity value when, or I'm sorry, the acceleration of the particle at the point where the velocity is equal to 0. So let's take our velocity function. We're going to set that equal to 0 and solve. And so we have to think about the unit circle. And where do we know that cosine and sine have the same values but different signs? Because that's going to be what we're really looking at here. In other words, negative cosine of t equals sine of t. Okay, and so that's really talking about over here in the second quadrant at 3 pi over 4. or at the 45s. So we're looking at 3 pi over 4. And so I need to know, well, what is the acceleration at 3 pi over 4? So now we plug that in up here, and a of 3 pi over 4. Let's see what we get here. This is where knowing your unit circle is probably going to come in handy. 3 pi over 4, well, sine is positive in the second quadrant, but the problem itself is negative. So negative root 2 over 2. And then cosine is negative in the second quadrant, root 2 over 2. So that's going to give me negative 2 root 2 over 2. And of course, those cancel. And so I'm left with negative root 2, which is answer choice A. All right, the free response in this section, we have a 12,000 liter tank of water that is filled to capacity. At time t equals 0, the water begins to drain out of the tank at a rate modeled by. So keep in mind that R at t is a rate measured in liters per hour, and we have a piece loss function. And the very first question is R continuous at t equals 5. So I would compare from the left and from the right. So let's see, what would be the limit as R, I almost wrote X, approaches 5 from the left of R at t, and then we've got to compare that to the limit, and that's the question, the limit as R approaches 5 from the right of R at t. So from the left, when we go plug in, here we have 600 times 5, and again, this is a calculator problem, so from this point on I would just be typing into the calculator. You have 1000 e to the negative 0.2 times 5, and when we plug in to the calculator, we should get one side being, let's see, I want to say one side was 375, and then the other side we would get 367-ish. So we had 367.879. So here we see that R is not continuous. At t equals 5. And I think this should be t over here. Okay. Now for part B, we don't know how to do B yet, so don't worry about that. We'll come back after Christmas and definitely do that. Now let's look at part C, and I'm actually going to put part C up here at part B. So we're not going to do part B, and then part C up here, find R prime at 3. So we need to tell our calculators to find R prime at 3, and when we do, it's going to be 50, and that's all calculator numerical derivative. Using correct units, explain the meaning of the value in the context of the problem. So whenever we have this, use that problem. Make sure you're using the context. So here again, R was a rate. So the rate that the water, because we are talking about water, and what is the water doing? It is draining. So the rate at which the water is draining out of the tank at, and make sure you quote what time, at t equals 3 hours, is increasing. And how is it increasing? It's increasing at a rate of, and here's our answer, 50, and we found the rate of a rate, so it's liters per hour, or hour squared. And that's all they needed, but here, make sure you can type that in your calculators. Okay, the next free response problem, the very first thing we need to do is find f prime at x. Now these are problems, look, you don't need to miss this. This would be crazy to miss. Now you do need to realize that f of x, you might be a good idea to rewrite this. Some people don't rewrite it. I just don't want you to miss it. So do remember that's to the 1/2. Start you a new line and say, all right, I know f prime equals, this is chain rule, 1/2 times 25 minus x squared raised to the negative 1/2 times the derivative of the inside. Now let's clean this up a bit, because of that negative exponent, we don't need to leave that. And we can also cancel out the 2 and the 1/2. Not necessary, but you can. And it's okay to put equals over here. And then just make sure you don't say this function is equal to this function, because it ain't. All right, so we have x over, negative x, don't forget your sign, over the square root of 25 minus x squared. There's your derivative. You are done. Drop the mic and run away. That is done. Okay, now for part B. Part B tells you to write the equation of the tangent line. Y'all don't miss that problem. It is y minus y1. Here's just our general format. M times x minus x1. And notice x is -3. So I already know I'm plugging in -3 right here. Now to find y, we go back to the original. So we need to find f at -3. F at -3, well, that's going to be the square root of 25 minus 9, which is 16, so 4. So now I know that value. Now we need our slope, which means we need our derivative. But y'all, we already found our derivative in part A, so don't reinvent the wheel. Use the wheel. F prime at 3, well, we're going to plug in and get -3 over, and I've already plugged in -3 to that bottom. That's going to be 4, right? Because here I've already done that. Right there's that value, and plugging in, well, we did that right here. So we have all of our values. So we have y minus 4 equals -3/4 times x minus -3 or plus 3. So there is your equation of the tangent line. And don't box in anything, not necessary. All right, so for our next one, part C says, oh, but now I'm going to throw a function g in the mix. Is g continuous at x equals -3? Use the definition of continuity to explain your answer. So what's the first thing we need to find? Well, does g at -3 exist? That's always the first question. G at -3, well, g at -3 is going to be from this area. So g at -3 is really f at -3. And we found f at -3 earlier to be 4. Because it's not different, it's the same values we were using. So the next thing we need to do is find the limit as x approaches -3 from the left of g of x. And then let's find the limit as x approaches -3 from the right of g of x. And then we have to compare those values. So the limit from the left we found to be 4. We found that already up here. Look at how many answers it's repeating, but it's just asked in a different way. And then from the right, so we're going to plug into the bottom part now, and that gives me 4. So I know the limit exists. The limit as x approaches -3, notice it's not from the left or right anymore, it's just -3 of g of x, it equals 4. So now our last step, did my numbers from 1 and 2 equal each other? And they do. So I have the limit as x approaches negative 3 of g of x is actually equal to g at 3. So we have shown now that g is continuous at negative 3. And you can make that finishing statement that g of x is continuous at x equals negative 3.